Energy. People take it for granted, but fossil fuels we use these days are running out. For years, scientists have been trying to find a sustainable source of energy, and they came up with nuclear fission. It produces a lot of energy, but then another problem arises: nuclear waste. Is there a better way? Of course, nuclear fusion. Nuclear fusion involves two atomic nuclei joining to make a large nucleus. Energy is released when this happens. The sun and other stars use nuclear fusion to release energy. The sequence of nuclear fusion reactions in a star is complex, but overall, hydrogen nuclei join to form helium nuclei. I'm going to show you an example of a nuclear fusion reaction. Here we have a hydrogen 1 nuclei and a hydrogen 2 nuclei. The process of fusion between the two releases a lot of energy and forms a helium 3 nuclei. Just like nuclear fission, nuclear fusion releases heat energy. However, in nuclear fusion, two nuclei must join together and extremely high temperatures are needed. These high temperatures are difficult to achieve, and it is difficult to safely manage the extremely hot gases produced. However, the oceans could provide almost limitless amounts of the hydrogen isotopes needed for nuclear fusion. So scientists believe that it is worth trying to design and build a fusion power station. This is so expensive that several countries are working together on the project.
In space, there are huge clouds of dust and gas. These clouds are formed because of gravity between the particles. The attraction causes the cloud to become larger and larger. If one of these clouds is big enough, its own gravity causes it to collapse. And towards the center of the cloud, it gets denser and denser and hotter, until eventually the particles are so close together and the temperature is so high that they begin to fuse together. This is the energy source of a star, and it begins to shine. At the beginning of the life of every star, there are only hydrogen nuclei, and they fuse together to produce helium nuclei. But what happens after this depends on the size of the star at its birth. For a star like our Sun, it is in a delicate balance between its own gravity, which makes the star want to collapse in on itself, and the pressure that pushes outwards that comes from the energy produced by fusion.
However, the hydrogen eventually runs out. The pressure is lost and gravity makes the star collapse in on itself until the point where it is hot enough for the fusion of helium atoms to form carbon and oxygen. As it fuses helium, the energy released is more than gravity, causing the star to expand outwards. Our Sun will one day grow to engulf all the inner planets of the solar system and becomes a red giant. As the star expands outwards, the effect of gravity on the outer layers become less and less until the outer atmosphere of the Sun drifts off into space, expanding to become a planetary nebula. At the end, all that is left is the core, an extremely dense and extremely hot white dwarf star. It is dead, and there's no nuclear fusion, so that over millions of years, it cools down to become a black dwarf.
For stars larger than our Sun, they are able to fuse heavier and heavier elements, so that eventually some grow to become 1,000 times the size of our Sun. And this is how they're heavier elements than helium in our solar system, because it is believed that our solar system are the remnants of what was once a red supergiant. It eventually gains an iron core, and once that point is reached, no more energy can be released from fusion, and the core collapses and is compressed into neutrons. When the outer layers collapse in, they bounce off to form an outward propagating shock, and all the surrounding materials is blasted away in a supernova explosion. Now, all that is left is a neutron star, the remnant core of a red supergiant. For the largest stars of all, it is believed that when they collapse, gravity is so strong that a black hole is formed. No, I can't even hear it. There. Okay, I tripped up on. I missed it together!
This is a fusion as it fuses helium. One more time. Fusion of helium. Helium. One more time. 'Cause baby, there ain't no mountain high enough.